Get ready for a cosmic disaster of never-before-seen scale. Betelgeuse, the red giant star on the edge of our galaxy, is sending frightening signals through space. Astronomers have found something deeply troubling about this massive object using the James Webb Space Telescope. Renowned scientist Brian Cox has issued a very serious warning. The question that keeps coming up is, are we about to witness a supernova explosion that will change the night sky forever? Let's jump right in. In the vastness of the universe, stars are born, live, and die in amazing ways. Recently, one star has caught the attention and concern of both astronomers and the general public: Betelgeuse, a red supergiant star in the constellation Orion. It is incredibly massive and ancient. Its unique reddish color and varying brightness have long been intriguing, but recent events have heightened interest in this cosmic giant. As we learn more about Betelgeuse, we are on the verge of a potentially monumental event in its history. But what might these changes in Betelgeuse mean? Are we witnessing the beginning of a cosmic spectacle on an unimaginably huge scale? Betelgeuse is a stellar giant, approximately 764 times larger than our Sun. Its size is almost beyond human comprehension. Imagine a star so immense that if it replaced our Sun, its surface would extend beyond Mars's orbit, enveloping Mercury, Venus, Earth, and Mars. This colossal size not only illustrates the physical grandeur of Betelgeuse, but also indicates its stage in the stellar life cycle. As a red supergiant, Betelgeuse is nearing the end of its life, expanding and cooling after exhausting the hydrogen in its core and fusing helium. What about Betelgeuse's age? This star is estimated to be between 8 and 8.5 million years old. While relatively young in human terms, it is ancient in stellar terms. Over millions of years, Betelgeuse has undergone dramatic transformations, evolving from a hot blue star to the red giant we observe today. It is now in its final stage as a red supergiant. Stars like Betelgeuse change throughout their lives due to the ongoing pressures of nuclear fusion and gravity. Another characteristic that makes this stage of Betelgeuse stand out is its unique reddish color. Its red hue arises from its cooler surface temperature compared to other stars like our Sun. The Sun's surface is around 5,500 Kelvin, while Betelgeuse's surface is about 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light at wavelengths that make it appear red. However, this color is more than just an appearance. It reveals information about the star's physical state and the processes occurring within its vast gaseous volume. The fact that Betelgeuse's color has changed over time adds to its mystery. Historical records from Roman and Chinese eras indicate that Betelgeuse was yellow around 2,000 years ago. By the 9th century, Arabic astronomers noted its red color. This shift over the course of human history is not merely a historical footnote. It signifies the star's evolution. Another intriguing aspect of Betelgeuse is its changing brightness. It is a semi-regular variable star, meaning its brightness fluctuates periodically. This rhythmic dimming and brightening have captivated scientists and stargazers for centuries. Typically, Betelgeuse goes through a 400-day cycle and a longer 5-year cycle. As early as 1836, Sir John Herschel documented these cycles, and Aboriginal folk histories may date back even further. However, what truly makes Betelgeuse mysterious is not just its brightness changes, but their irregularity. Unlike many stars that vary in brightness predictably, Betelgeuse sometimes deviates from this pattern, suggesting complex and less understood processes within its immense form. Recently, astronomers and stargazers worldwide were shocked to observe a dramatic and unexpected change in Betelgeuse's appearance. This unprecedented dimming has raised numerous questions and concerns. This is now known as the Great Dimming. In late 2019, the red supergiant Betelgeuse, one of the brightest stars in the night sky and a prominent feature of the constellation Orion, began to dim mysteriously. The star was dimming so rapidly that it started losing its light at a rate of 0.1 magnitudes per day on average. By February 2020, it was at its dimmest. Betelgeuse, which can usually be seen with the naked eye even in areas with significant light pollution, became much fainter, and even casual observers could notice the difference. The time paradox, however, complicates monitoring Betelgeuse's activities. Because light takes so long to reach us, when we observe a star like Betelgeuse, we are not seeing it as it is now, but as it was in the past. For Betelgeuse, the light we see today left the star almost 700 years ago, as it is about 725 light-years away. This time lag makes predicting and monitoring rapid changes in its behavior challenging. The Betelgeuse dimming event highlighted the difficulties of real-time sky observation and our limited understanding of the vast and mysterious realms of space and time they inhabit. Andrea Dupree, Deputy Director of the Center for Astrophysics at Harvard and Smithsonian, and her team closely monitored Betelgeuse's celestial drama as part of a 3-year study to track changes in Betelgeuse's outer atmosphere. They used the Hubble Space Telescope to observe the massive star. These observations provided new insights into how a variable star like Betelgeuse operates. Variable stars regularly expand and contract, causing changes in their brightness. Researchers were able to examine the layers above Betelgeuse's surface, heated partially by the star's swirling convection cells, thanks to Hubble's sensitivity to ultraviolet light. Further analysis of Hubble spectra taken at different times in 2019 and 2020 revealed the movement speeds in Betelgeuse's upper atmosphere. The spectra were primarily composed of magnesium-Roman-2 lines, indicating the star's atmospheric conditions. The study showed that material was moving from Betelgeuse's surface into its atmosphere at about 200,000 miles per hour. This hot, dense material eventually traveled millions of miles away from Betelgeuse, forming the dust cloud that dimmed the star during the 3 months of the outburst. Dupree and her team estimated that about twice as much material as usual was ejected from Betelgeuse's southern hemisphere. While all stars lose mass over time, Betelgeuse's mass loss was particularly notable because it occurred at a much faster rate than the Sun's. Astronomers debated whether this event could signal an impending supernova explosion, given the magnitude of the mass release and the subsequent dimming. Being only about 725 light-years from Earth, Betelgeuse adds to the intrigue, as any such explosion would be visible from Earth and offer a rare opportunity to observe a supernova up close. But the question remains, what does this dimming mean for Betelgeuse's future? Is it a sign of an imminent supernova, or is it merely a one-time event in the star's long and complex life? Several theories have been proposed to explain this rapid change. One popular theory suggested it was a precursor stage in the supernova explosion process, gaining traction due to the belief that Betelgeuse is nearing the end of its life. Another common theory posited that dust, possibly from the star itself, was obstructing our view. It is known that Betelgeuse and other red supergiants shed material, which could accumulate into a dust cloud thick enough to obscure the star's light. A third theory examined how changes in the star's photosphere, the visible outer layer, might affect its apparent brightness. This puzzle was tackled using a combination of observational techniques and in-depth analysis. Spectroscopic studies indicated that Betelgeuse's effective temperature dropped, suggesting that the star may be dimming due to a large dark spot on its surface. The fact that Betelgeuse's temperature dropped by at least 170 Kelvin around the time of the dimming supported this idea. This indicated significant changes on the star's surface. In the end, the Hubble Space Telescope, humankind's watchdog in space, helped us understand what was happening with this unusual event. Hubble's observations showed that the dimming of Betelgeuse was likely due to a large amount of hot matter being injected into space. This material formed a dust cloud that obscured part of the star's surface, reducing the amount of light reaching Earth. The dust cloud was believed to consist of very hot plasma that erupted from a large convection cell on the star's surface. As this plasma moved through Betelgeuse's hot atmosphere to cooler outer layers, it formed dust grains that created a cloud-blocking light from about a quarter of the star's surface. Hubble's ultraviolet light spectroscopic studies, which began in January 2019, were crucial in piecing together the events leading up to Betelgeuse's dimming. These studies detected dense, hot matter moving through the star's atmosphere in the months before the dimming. Several ground-based telescopes also observed the star's brightness decrease in December 2019, particularly in its southern half. Initially, the ejected material was brighter than the star itself, but as it moved outward and cooled, it turned into a dark cloud. This outflowing matter and the resulting dark cloud were believed to be responsible for the sudden dimming of the star. This explosion was immense, putting Betelgeuse at the center of astronomical attention. The star expelled about 400 billion times the mass typically ejected in a normal coronal mass ejection. This material, thought to be several times the mass of the Moon, was significant for both Betelgeuse and our understanding of stellar processes. What does such a massive ejection mean for theories about Betelgeuse and supernovae in general? It has profound implications. Red supergiants like Betelgeuse are thought to lose mass at a fairly steady rate before they explode. As supernovae, this idea was tested and explored by an international team of astronomers. As they continue studying Betelgeuse, their findings could change our understanding of how stars evolve before exploding. Betelgeuse is approaching the end of its life, as we all know, but that does not mean it will explode into a supernova soon. Scientists now believe that Betelgeuse will undergo many more mass ejections in the years leading up to the eventual supernova explosion. So, don't hold your breath for a supernova tonight, but keep your eyes on the sky. In about 100,000 years, Betelgeuse will finally reach its grand finale, dying in a spectacular supernova explosion visible from Earth. This cosmic spectacle will not just be a dazzling display, it will provide astronomers with an unprecedented opportunity to study supernovae in detail. The recent great dimming of Betelgeuse has sparked scientific curiosity and concern, underscoring our limited knowledge of stellar processes, especially those leading up to supernovae. With advanced telescopes like Hubble and the forthcoming James Webb Space Telescope, scientists hope to capture and understand the many more exciting moments to come in Betelgeuse's life. We are on the edge of a stellar revelation. We are watching the skies for what might happen next in this cosmic drama. This is your daily dose of geeky space facts. I hope you enjoyed this story about Betelgeuse and the cosmic secrets it holds. Until next time, keep looking up.